My dear children, today I am presenting a new lesson of statistics that you know as data representation and interpretation. Under this theme, today we are going to learn about histogram. Before beginning the lesson, we should know what knowledge we are acquiring throughout this lesson today. After studying this lesson, that means if you watch this video carefully and actively, you will learn how to construct a histogram for the frequency distribution of continuous data in equal size class intervals and also when the class intervals are not in equal size. Methods and theory behind this we can learn while doing this lesson. Therefore, don't worry about these big terms, okay? Okay, children, tell me what is a histogram and how it looks like. A histogram is the most common graphical representation of a group frequency data, and it looks like very similar to a bar graph, but there are significant differences between them. Now, can you see these two pictures? Bar graph and histogram. Now, we'll compare these two diagrams, okay? The bar graph is the graphical representation of categorical data, qualitative data. A histogram is a graphical representation of a quantitative data. The second comparison, in the bar graph, there is equal space between each pair of consecutive bars. But, in a histogram, there is no space between the consecutive bars. And in the bar graph, the height of the bars shows the frequency and the width of the bars are same. But in histogram, the area of the bar proportional to the frequency. If I explain in another words, the area of a rectangle shows the frequency of the respective class interval and the width of the bars need not to be same. Okay, now we'll construct the histogram for the data distribution with equal sized class intervals. First, we have to have a graph paper. The horizontal axis representing boundaries of the class intervals with appropriate scale and the vertical axis corresponding frequency of respective class intervals. Now, with this example, we are going to learn how to construct a histogram. So you can see class intervals are given 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. So here all class intervals are same. Class width is 10. X-axis representing the class boundaries, 10, 20, 30, 40, 50, 60. Vertical axis representing frequencies. Now look at how can we construct the bars now. The first class interval 0 to 10, we take the gap as 1. So frequency should be equal to the area of the bar, therefore 1 times 4. The height of the bar is 4. Similarly, height of the second bar 10 to 20 also 5. 1 into 5, 5. 20, 30 also the same. So 1 unit into 12, height of the third bar is 12. Then 30 to 40, the same gap, the 1 into 7, height is 7. 40 to 50, that particular class interval, the respective height of the bar is 3. Okay, you learn how to construct the histogram. Now children, pause this video. See whether you can construct a histogram for this data distribution. Well, shall we discuss this again? This data distribution, we have two problems to fix. Number 1, the class intervals are given starting from 130. So how can we fix these class intervals on x-axis? To maintain the accuracy of the scale on x-axis, we need to insert a small cut near 0 on x-axis, right? So then we know in between that cut, we have showed our scale from 0 to 130. The second issue is upper bound of the previous class interval is not the lower bound of the next class interval. There is a gap between the upper limit of the previous class interval and lower limit of the next class interval. If we draw a histogram with this gap, it is actually not a histogram. Can you see? We learn there are no space between two consecutive rectangles in a histogram. So we need to address this issue. Then we'll find a way to remove this gap between the upper limit of the previous class interval and the lower limit of the next class interval. To avoid this problem, we need to take the boundaries of the class intervals. Now again pause the video and complete the class interval and the class boundaries. Okay, well, we'll check 130 to 134. So the plus minus 0.5. So 129.5 to 134.5. 135 to 139, 134.5 and 140.5. So like that, we can remove the gap between the upper limit and the lower limit by adding 0.5 to the upper limit, subtracting 0.5 from the lower limit. Fine. We have addressed both the problems we have with this distribution. So now we can draw the histogram as usual. You all can do it. Since the class width is same, we can draw this histogram using the previous steps. It is not a big deal for you. No brainer. Okay? Now our next task is drawing histogram with unequal size of class intervals. In this question, 7 class intervals are given. First 5 class intervals maintain their equal class width of 10 gaps, 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. And 50 to 70, we have 20 gap. 70 to 100, we have 30 gap. The last 2 class intervals, they have different class widths. We know that the areas of the columns are proportional to the relevant frequencies of each class interval. Here you can see the size of the smallest class interval is 10. By dividing size of each class interval by the smallest class interval, we can find the scale factor. So simply 10 gaps is equal to 1. Therefore, we'll check how many units are there in each class interval. 0 to 10, 10 divided by 10 is 1. 0 to 20, 10 divided by 10 is 1. 20 to 30, 10 divided by 10 is 1. 30 to 40, 10 divided by 10 is 1. 40 to 50, 10 divided by 10 is 1. 50 to 70, the class size is 20, divide by 10, 2. 70 to 100, class size is 30, divide by 10 is 3. This is how we have to find the height of the class interval. Then we know area of the column is equal to class width into height of the column. Height of the column we can find area of the column divided by class width. Since area of the column is equal to the frequency of particular class interval, we can divide frequency by class width. Okay? That is how we have to find the height of each rectangle. Accordingly, height of the first rectangle 2 divided by 1 is 2. Second rectangle 4 divided by 1, frequency is 4, class width is 1. 4 divided by 1 is 4. The third class interval, frequency is 6. 6 divided by 1 is 6. Fourth class interval, 9 divided by 1 is 9. 5 divided by 1 is 5. Then the 50 to 70 class interval, frequency is 8. 8 divided by class width, height is 4. 70 to 100, the class width is 3, frequency is 6. So 6 divided by 3 is equal to 2. Know the class boundaries and the height of the column. So we can follow the same steps to construct the histogram for this question also. Now observe this histogram. When you multiply class with the height of the class interval, you are getting the area of a rectangle. So that area of a rectangle is equal to the frequency. 50 to 70, we know the width of the class interval. We take as 2 units into 4. 2 times 4, 8. 70 to 100, we know the gap is 3 units into 2, 6. That is how we construct histogram for a unequal size of class intervals. Dear children, hope you understand this lesson. Again, we have to learn one more topic, frequency polygon. Hope to meet you with that chapter in next video. Thank you everyone. Hope you will enjoy with these videos and use these materials as much as possible and try your best to success in your maths journey in your life. Good luck.